Hi, it's me again. Miss Huff, remember me? Hey, speaking of while we're looking, don't forget to like and subscribe. Actually, subscribe. It really helps me out, guys. How many times have you watched videos and heard that? But actually, subscribe. It'll help you too, so you can see when I upload videos. So let's talk about weather and climate. Weather, we're talking about the state of the atmosphere at a specific time and place. So we're talking short periods of time. So if you look outside today and you see what it's like, that's weather. Is it sunny? Is it cloudy? Is it raining? Is it snowing? Is it hot? Is it cold? That's weather. What about climate? It's the average weather of an area over a long period of time. So you can think here where we live, we have hot summers. We have in September a rainy part where there's like hurricane season. We have cool winters where we might get a snow or two in that time, but the winters are not long or intense or cold. We have a warm spring and a warm fall and a hot summer. That's like our climate. It's basically the same year after year after year. So the interaction of water, sun, and air, that's what causes our weather. Throughout our other videos, you can kind of have seen like Earth's place in space. You've seen the sun kind of have like what angle the sun comes in is going to determine the intensity of the light and heat that we get. And it's going to heat up water and produce water vapor, produce clouds, produce rain. So that's where we're going to get weather. And then because of where the Earth is at the time, things are going to be kind of the same year to year because of where the Earth is and the amount of sunlight it gets every year, because that's unchanging. And the prevailing winds that are on the planet, that's kind of unchanging. So that's where we get climate. So you can kind of eventually at some point talk to someone about weather and stuff. You don't have to do that right now because you're probably all at different points. But if I was there, we kind of talk to each other and we discuss what we know about weather and climate. So the sun, like we've been talking about, provides Earth's energy. It's energy for photosynthesis, for living things. It's the energy that drives the water cycle. It's the energy that drives prevailing winds that cause like weather and climate. And so this energy is going to cause evaporation of water from the hydrosphere and into the atmosphere, and it's going to fall back down to Earth as precipitation, rain, sleet, snow. The sun's energy also heats the Earth's surface, which then heats our air. And due to that unequal heating, so maybe more intense at the equator and very not intense at the poles, that's going to cause unequal heating, and then that's going to cause wind and water currents. So we have ocean currents, air currents, and that heat gets moved around the Earth through those and redistributed. Take a look at this video. I got to put a link. I'll put a link on Google Classroom for you to watch. So that'll just kind of review things for you. But pause here, take a look at that video. And in your life, you've seen weather changes frequently. What factors cause weather to change? Pause and think about that. What's going to cause the weather to change? Well, movement of air, right? The air's going to move, and we're going to see like clouds come in. We're going to see maybe the clouds move out. We're going to get, if the wind comes in, we're going to get a change in temperature. So air pressure, the change in air pressure is actually wind. You're going to get a change in air temperature, humidity. Oh, you know what you should do? There's a video that I did it for AP Environmental last year. But I tried to explain humidity and dew point. Take a look through my channel. I've got videos. This is why you need to subscribe. Take a look through my channel and find the video on humidity where I kind of explain humidity and dew point and how that causes rain. Clouds, whether it's cloudy or sunny, is going to affect the temperature. If it's cloudy, then the sun's not going to be as intense. Rain, snow, precipitation is going to affect the weather. We don't have this. Don't even worry about that. But these are just factors of weather. You don't need to do that. Air temperature, wind, and humidity are all connected to this thing of air pressure. And then air temperature. That's how hot or cold it is outside. Temperature is a measure of the... Okay, so this is what's cool about temperature. And I think you should have learned about this in chemistry. But temperature is actually the movement of particles. So if you put your hand on something that feels cooler than your hand, the particles inside that are moving slower than what's in your hand. If you touch something that's hot, the particles, the atoms in there are moving faster than what's in your hand. So temperature is just a measurement of the movement of those particles. I kind of ruined this. So does warm air have faster or slower moving particles than cold air? Hotter things have faster moving particles. Slower moving particles feel colder. So in something like space, there's no particles. But if you go somewhere cold, the atoms are moving much slower. Even in solids, the atoms are moving. So the temperature of a substance is related to the speed of the substance particles. I'll put a link of this later for you guys. I don't know if this still works. So don't worry about that. But as the temperature of a substance increases, the particles in the substance are moving faster. That causes the density and pressure to decrease. And all those things are connected. It's like the gas constant, PV equals nRT, but you don't need to know that. If we were taking physics, then we'd need to know about gas constant, Pascal, and all that. But as the temperature of a substance decreases, the particles in the substance move slower. That means higher density, higher pressure. You know what's an exception to that? Ice. Ice, when it's cold, the particles are moving slower. This is one of the only substances where the density is less. So water is the exception to this rule. Remember, think ice floats on water. So that's the only exception I can think of to this rule. And if ice and water didn't behave like that, we wouldn't have life on Earth. But that's another story. So here we have something cold. They're kind of close together, moving slowly, and particles that are hot, they're kind of spread a little bit farther, moving faster. So colder things, higher density, higher pressure, lower particle movement, lower temperature, and hot is the opposite. So if you feel like making a little diagram, you don't have to draw all these things, but that's just how these particles are moving in hot and cold things. So let's look at infrared images of Earth. I've got a little thing here. I'll have to, you know what I'll have to do is put these notes up on Google Classroom for you so you guys can click on it. Thinking. I think this should still work. But if we look at surface temperatures of the Earth, we're going to see like hotter near the equators and colder near the poles. And we'll also see that the land gets hotter and colder faster than the ocean. Why is that? Water has a high specific heat, which means it takes a lot of heat energy for water to get hot, and then it takes a longer time for the water to cool down. That's just how it works. So warm air temperature is warm feeling weather, and cold is cold feeling. You don't say. Just making sure you guys understand that. Okay, what about wind? Wind is air moving in a specific direction. Why do we get wind? It's from the uneven heating of Earth. Okay, it's going to try to even out, and so the air is going to move. So what determines the direction of the wind? Well, wind has to do with like moving air particles. Now everything wants to be balanced and even. I don't know if you remember that from chemistry, if you took chemistry, or from me when I talked about osmosis and diffusion. Everything wants to sort of be even. So where there's lots and lots of particles, so where there's high pressure, it's going to move to low pressure. So all the little particles are going to move from high to low. Remember biology? Remember osmosis and diffusion? Things are going to go from high to low, high pressure to low pressure. So that's the direction wind's going to move. Okay, so what is that, left or right? It's wherever there's high pressure to low pressure. Watch the TV weather news. I don't know if you don't have cable or whatever. Watch it online. Look at a newscast of the weather online, where they're showing the high pressure. Wind is going to move from that out to where there's the low pressure. That's just the direction it's going to go. So how does wind influence weather? Well, I think that you can kind of work that out or think that out. Let's take a look. So wind is going to help redistribute or move Earth's heat. So it's going to move from high temperature to low. So it can make the weather colder or warmer in an area, depending on what wind direction is and where it's moving. You don't need to do this. If we were in class, we would talk about it. I know you kind of have to do things on your own. Sorry. do this in your notebook. Just write to yourself in your own words difference between weather and climate. You can probably look back up at your notes and see it. But put it in your own words. And describe how temperature and wind affect weather. Let's see here. Hold on 1 second. We're just gonna do this. Hey, so I don't have video editing software, as you can tell, but here's why I'm not at work. See? That's my little man. He wanted to be on the TV, right? You wanted to be on the screen, right? No? Okay. Well, this is why I'm not here. But I'm thinking about you guys, and I miss you guys, but he needs lots of care. So that's why I'm here and not there. Just saying. Okay, sorry. Remember, no editing software, and I don't have time to edit, to be honest. Okay, anywho, if I was there, we'd kind of talk about this, and I'd have you guys do this. But don't worry about it right now. So heat is going to evaporate water into the atmosphere, and where does it go? Well, water vapor is going to go into it. It's just going to be part of the atmosphere. Remember, we've talked about that. Our atmosphere is mostly nitrogen and oxygen, but it's also carbon dioxide and water vapor and other trace gases like carbon monoxide, hydrogen, like sulfur dioxide. There's tons of other gases in our atmosphere. So the water vapor molecules are just going to be in the air. They're in the air around you. You're breathing them out. They're just in the air around us. There's not a ton of them, but they're there. Excuse me. So think about the water cycle. Those water vapor molecules, they're just in the air. Well, eventually they can cool and condense back into liquid and form a cloud. And then eventually, like if it reaches a certain point, like it reaches like the dew point, then we're going to end up seeing rain or snow, precipitation of some kind, and it's going to come back down. So water vapor can be evaporated. It's right here in this blue space here. Well, I don't see it's on a cloud. That's right, it's just there. It's literally around your face right now, especially as you're breathing out. If it gets cool enough, that's when it will condense and form into a cloud. Kind of like when you're outside and it's really cold and you breathe out and like you see a little cloud, that water vapor that you breathed out condensed, and then it just went right back to gas again. So that's how that goes. Okay, so just think about the water cycle. So humidity is the amount of water vapor in the air. So think of a hot summer day. Did you ever walk on a hot summer day like through like some tall grass and just feels kind of sweaty around your legs and stuff where the tall grass is? Well, that's the water vapor. Or you're like, oh, it's so humid out. It feels like sticky and stuff. Well, the more humidity, the more water vapor there is in the air around us. And hot air, warm air, can hold more water than cool air. So like why am I pointing? That guy's cup might be cool air, and my coffee cup might be warm air. See how mine's bigger? So warm air can hold more water than cool air, water vapor. So humidity, if you want to write that down, it's the amount of water vapor present in the air. Like I said, I'll put this up on Google Classroom so you guys can look at these notes and click on these things. Some of them I'm not sure if they still work anymore. But hot air can hold more water vapor than cool air. Okay, that's why it feels hot and humid. That's why it feels more humid in the summer than it does in the winter, or why it's like dry and you like chapstick and stuff in the winter. Cool, wintry air can't hold as much water vapor. And it's cold, so it's not evaporating. So, air doesn't always contain the same amount of water vapor. And like I said, more water vapor can be present when the air is warm than cool, but why? Okay, well, let's take a look at that. What's happening to the movement of particles when the temperature is warm? In warmer temperatures, the particles move faster and they don't easily come together. But in cool temperatures, the slower moving particles allow water vapor to stick together and form water droplets or condense. So they're going to condense and form a cloud more easily in cool air than they will in hot air. And that's why. So how is humidity connected to air pressure? Well, cooler temperatures have lower pressure or lower density and lower humidity because the water vapor condenses faster. And then how does humidity affect weather? What a great question. What great questions you guys are asking. Low humidity is when the air feels dry. Hey, look, that's right where I'm from. Low humidity. Yeah, not in the summer. High humidity is when the air feels damp or sticky or muggy, and high humidity can make the weather feel warmer than the actual temperature. Got 'em. Smothered and covered. Waffle House. Okay, anyway. So let's talk about humidity and dew points. So I've got my little video that visually will show you what happens. Okay. So here, let's pretend it's a summer day. Bless, on this summer, and it's 87. Well, and this thing called the dew point is 65. The dew point is the point at which the water is going to condense and form a cloud. So we won't see any clouds here. We won't see fog because the temperature is higher than the dew point. That would be like this picture, and then where my head is near, we've got 6 ounces of water in a 12-ounce glass. So the glass isn't full. We're not going to see any sort of water come out or anything. As we go up in the atmosphere, the temperature drops. Think of your layers of the atmosphere. The temperature is going down. So it's 76 degrees. The dew point's still 65, so no clouds. But the point at which the temperature and the dew point are the same, we're going to see condensation. We're going to see a cloud form. Then, as we see like the humidity, once humidity gets to like 100%, like 6 ounce glass, and we have 6 ounces of water in it, as soon as the humidity tries to increase above that, like it tries to go to like 9 ounces, well, what's going to happen? It's going to spill over the glass, and that's like rain. That's like precipitation, right? Okay, so that's how you get precipitation. So what do you think about a perfect day? Would you rather have low humidity or high humidity, and why? Think about it. You can always think about it, talk to a person. Well, that's what we would do in class if I was there. Do you know how clouds form? You can try to talk to someone. Probably just hang out and kind of think about it. You can always look it up. But we kind of just talked about it a little bit. But how do clouds form? So a cloud forms when warm air rises. Remember that warm air has water vapor. The warm air rises, expands, and cools, and so the water vapor in it then will condense and form a cloud. So it's condensation. So how might clouds influence weather? Clouds prevent the sun from coming, and the sun's rays from coming to Earth. I mean, some sun still gets down here. It's still like not pitch black when it's cloudy out. But we have less incoming solar radiation. So less of the sun's radiation is hitting the Earth, and it causes a cooling effect. So it's cooler when it's cloudy. Clouds can also trap some of Earth's heat and reflect it back down. So, and clouds are also obviously a source of precipitation. So that's going to cause things like rain and snow. So think about it. Are clouds good and bad for weather? Well, what does good or bad mean? So what do clouds do for the weather in terms of weather? So we've got our precipitation. That's rain, sleet, snow, hail. So you've probably experienced all of those in your lifetime, but that's what precipitation is. It occurs when the water droplets combine in that cloud and grow large enough to fall down to Earth. So here's a little picture of it. By picture, I mean GIF. And no, I don't mean GIF. I don't care. That is a hill I will die on. I don't care that the guy who made it calls it GIF. He's wrong. Okay, it's a GIF. You don't get a gift for Christmas or for your birthday. You get a gift. Anywho, air temperature determines whether you're going to have rain, sleet, snow, or hail. I mean, obviously, if it's above 32, you're going to have rain. If it's 32 or below, you're going to have snow. So rain, freezing rain is like when you have, it's going to melt in the warmer air, but then closer to the surface we have colder, so it's going to freeze on the surface. And then sleet, you have sort of a rain-snow mix, and then snow is just frozen water particles falling to the earth. Think about a time when that you've experienced when precipitation has affected the weather. Think about like not that long ago, we were off from school. I know, those are nice. Like I said, I'm gonna add this on there. I don't know if these work anymore, but I'll add this PowerPoint up there. So what I want you to do in your notebook, just you can write 531. So you can put 5 factors of weather are. 3 examples of how those factors affect weather are. 1 reason weather is not, my head is blocking the word not. 1 reason weather is not the same everywhere. Okay, so that's what you're going to do in your notes. So I hope that helps you understand weather, and then climate is just what we have over long periods of time. So hopefully you kind of understand weather now and the factors that influence weather. I hope that's helpful to you guys. All right, bye.